Welcome back to our Math 171 video series. In this set of videos, we'll go over how to write transformation form for quadratic functions. Here I have given you the quadratic function negative 3x squared plus 12x plus 8. We say this is quadratic because our biggest power is second power. That's the x squared. Our job here is to change this standard form I've given you into transformation form. I've already written the transformation form below, and that says y equals a times x minus h squared plus k. Let's go over what these letters represent in transformation form. The a in the transformation form is the leading coefficient. The h in the transformation form stands for the x-coordinate of the vertex. And then the k is the y-coordinate of the vertex. Every quadratic function has a vertex, and it's our job to locate where that is in order to write the transformation form. First, we will label each coefficient in the standard form as a, b, and c. A is always the number in front of x squared, b is always the number in front of x, and c is always the constant term with no x. Let's label those now. We can see in our standard form, our term next to x squared is negative 3, that will be our a. 12 is next to x, that's our b. And the constant is 8, that's c. We'll write that down over here on the left. Notice that we already know the leading coefficient, that's the a value. Since we can see that a is negative 3, that number will go in the first position. So we've taken care of one of our unknowns. Next we'll move on to h. To get the x-coordinate of the vertex, we'll use the formula negative b over 2a. And we've written down that b is 12, so on the top of this fraction we'll have negative 12. We've also written down that a is negative 3, so we'll have 2 times negative 3. This will give us negative 12 over negative 6 if we simplify, which gives us an x-coordinate of 2. So always remember that our x-coordinate h will always be negative b over 2a. If you know what b and a are, we can find the x-coordinate in just one step. Now we can get the y-coordinate. In order to get the y-coordinate, that's k, we plug in the h we just found into the standard form. We'll rewrite our standard form, but instead of writing an x, we'll write a parentheses instead. Inside that parentheses, we'll now place the h value we found, that's 2. Now we take care of the arithmetic. We have negative 3 times 2 squared. 2 squared is 4, times negative 3 gives us minus 12. Then plus 12 times 2, 12 times 2 is 24. And then we add 8. If we finish the math, negative 12 plus 24 plus 8 will give us 20. That will be our y-coordinate of the vertex. So our final transformation form will have us replace a, h, and k with the numbers that we found. We know the a is negative 3, we now know the h is 2, and we now know k is 20. So we'll say our transformation form will be y equals negative 3 times x minus 2 squared plus 20. This will be our transformation form. You may also be asked if your vertex is a maximum or a minimum. I've written the standard form and the transformation form to our right, but really the only thing we have to look at is our a value, our a being the leading coefficient. In our standard form, the a was next to x squared, but in the transformation form, it is the number in front of the parentheses. But in either case, it is negative 3. If a is a negative number, your function will open downward. Let's place a point at 2, 20, and allow our function to open downward. You can see in our function our vertex 2, 20 is a peak on top of a hill. If you have a peak, that means your vertex is a maximum. If a had been positive, we would still place a point at 2, 20. However, we would let the function open upward instead. Notice that this vertex 220 in this other form would have been a valley. And if you have a valley, you have a minimum. However, since our a was -3, that means our function should open downward and we will have a maximum. Also notice that on this graph, the quadratic function crosses the x-axis twice, and we should expect 2 x-intercepts. If the function had opened upward, notice that this curve would never have crossed the x-axis, and we could have expected no x-intercepts. In our next video, we will locate those 2 x-intercepts for our function.